And it's official. We're ready to start our second class. Welcome back, everyone. Well, we got through the introduction of the course on our Monday class. We did a little bit of work here. We're on now on example 2 on the first unit 2A. I changed this from section 2A to unit 2A. Our book prefers to call this a unit rather than section. So I think that's a good parallelism to match the language there. And our goal today is to kind of just refresh on some of the things that we discussed last time and make some more progress in 2A. But before we do any of that, any questions or comments at all, folks, to start us out today? Okay, well, let's begin. We talked again at length about a lot of things all at once yesterday, or not yesterday, on Monday. And I've always found personally that the first class can be pretty overwhelming because it feels like an avalanche of information. But if you would like, the kind of cool thing about our class is everything we do, our goal is to have recorded. So you can visit this link at any time, open that up, and that's going to take you to a playlist that has every recorded lecture. And sometimes I do make mistakes. I might forget to put the video in the playlist, or maybe I put this video in the wrong playlist or something like that. So if you notice that something's missing, just email me at any point and I'll get that corrected as soon as possible. But you probably don't want to read through or watch through an entire 1 hour, just about 9-minute video to determine exactly everything that was said on day one. So if you have any questions whatsoever about how the course is running at any point, don't hesitate to ask, email, drop in for office hours, and I'll be very happy to help out. Well, we're still just kind of getting started on the second day, and this is a pretty interesting class at 4 credits. We meet 3 times in the week, so we'll meet again on Thursday. That seems kind of rough Wednesday to Thursday, but we'll get through it. I just noticed a chat. Echo says, it's awesome you keep the recording to your lectures. Thanks for saying that. I think it's a pretty cool way to do classes this way as well. And what's kind of neat as well is if you're curious, I'm recording lectures for every single one of my classes. So you could just go to my YouTube, well, how would you say that, channel, I guess. And there's multiple playlists for other topics. And this stuff I hope to just leave there forever. I don't intend on monetizing it or anything like that. And so that'll just be an extra resource for us to work through. And well, maybe the first thing that we should kind of just refresh a little bit more, talk about is the homework system, MyLab. I checked the course a few hours ago, and it looked like close to 80% of everybody has registered in this so far. So good on you all for getting through that. If you haven't gotten to it, then no worries. You can get that done at pretty much any point. But if you run into any kind of technical issues or any kind of confusion, don't hesitate to reach out, and I'll be happy to help. Let's go back in there again just to take another look at this system. So Access Pearson takes us to both the textbook and the homework problems for the course. It's kind of a chore because you click on this link, then you click on Open Pearson. If you're already registered, then you'll see something that says Open MyLab and Mastering. It's called MyLab and Mastering on that link. And then when you get inside, it's called MyLab and Math. It's like they can't determine or make up their mind on what they want to call this. I'll often just call it MyLab for short. And I want to go to the student view. This is more like what you would actually see. So this is the experience for both the textbook and the homework. Like we talked about last time, you can click on this link. And this link right here, this will open up the textbook. And it's a pretty standard digital online textbook that you might expect to work in. Click on Open Textbook if you wanted to go to just the last page you're on, or Table of Contents if you need to jump around. And like we mentioned before, this is what the reading looks like. This is not where the homework problems are. I mean, there are homework problems at the end of each section. This is a very faithful reproduction of that real textbook. But this is where all the reading is going to be found. So when it says on the Canvas course page, read Unit 2A, that's what we're referring to, reading that particular section here in 2A. You can also just pop out the table of contents, go down to Chapter 2, Unit 2A, to start from the very beginning. Really, this is kind of just a fast refresher, just a reminder about the textbook, where to find it, how to work with it. But the other thing that people are typically more interested in is working the homework system itself. So let me make sure I'm back in the student view. You'll go down to, you can view this through the calendar or just go down to the list that's going to be built up here as we add more and more sections. The due date says January 22nd, and that means I intend to have this section completed. I thought that'd pop out a calendar. I tend to have this section completed tomorrow on the 15th, and I'll be putting in a 1-week turnaround for all the due dates. So clicking on this takes you to the list of homework problems. You can do them in really any order, but I think for the best experience, clicking on question 1 and going problem to problem is probably a more wise thing to do. So if you click on question 1, here's what it looks like once it finally loads in. Its problem's pretty similar to the ones that we're doing in the course notes. We'll work these out step by step, put in an answer, and pretty much this is what the homework system looks like. We'll practice a little bit in here with some problems as we get further in the lecture notes, just to demonstrate the system a little bit more. But really, this is just a short refresher at the start of class, just to remind us how this stuff works. Any questions or comments at the moment?
Yeah, I had a question about the homework. Will it be able to be accessed after it's already turned in if we wanted to use it for study materials or something later on?
Yeah, absolutely. So there's lots of ways to come back here and practice further on. The way that works, I'm going to have to kind of review that. So let me put in a quick reminder here. Let me put in new Word document. I don't put in this reminder just like this. I'm going to forget the question. That's a very good one. Find out how to go back to a homework assignment for the purpose of review practice. Yes, I do know it's possible, and I'll look into that really carefully and come back possibly on Thursday with instructions on how to do that, or maybe next Monday. Thanks for asking about that. That's a really good question. Other questions at the moment? Okay, so one thing I want to mention is when you click on question 1, if I recall here, I thought I was looking for a particular statement that I thought I would say. I think I've been in my lab at some point, and it did say putting in problems here will affect your score, which is a way for the system to say you're not in a review mode, you're in actually doing the homework, but doesn't seem to be doing that now that I'm looking at it from this desktop. Well, let's close that out. And again, we'll talk more and more about the homework system, getting extra help in it, all the additional features. I'd say for the build-up of the course starting off in week 1, we're not trying to do a million things at once. If you're already registered in Access Pearson, then you're in great shape for being caught up in the course. And I would say before class on Thursday, if you get inside there, maybe play around with the problems, seeing how it works, do a couple problems, let me know how it goes, then you'll be in really great shape for next class. And as you mentioned, I'll take a look into how to go back to the homework sets to do it for the purpose of review. Well, we're back to the Canvas course page. Our goal now is to make some more progress in Unit 2A, but any questions so far at the moment? Okay, let's give this a start then. First, one of the things I want to mention is essentially every single thing we do in class is recorded some way, somehow, either in the recorded lectures, but also in these PDF documents that are posted right here. So if I open this one up from the Canvas page, it looks like this. It's not the same document from the first day of class. Trying to open it slightly differently. There we go. All the work that we did last time is now presented here. And so you're always going to have a very good idea of exactly what we did last time, where we're at in the unit, whichever particular unit we're working in. We're now on example 2. And if you want to access the blank PDF, they're all going to be contained in here. We mentioned this before, but again, we said a million things, it feels like, last Monday. So just a refresher, all the actual blank notes, if you need a copy, can be found here. This is the Word version if you want to write on it with a digital pen like I'm doing in class. And the PDF version is really just for ultimate compatibility. This is the best one to print, for example. Okay, let me open up the Word file associated with this one. Oh, I guess I had it open already. Here it is. So we were working on some extra concepts at the very start of these notes before we get into some of the bigger ideas of just refreshing fraction arithmetic. We ended class a little bit early last time, working out multiplying different fractions. And the review of how that went is the formulas are kind of mysterious in a certain sense because the book says it to do it one way. You take a times c, multiply across the numerator, and then you take b times d, multiply across the denominator. But did we ever actually do that? Maybe once in method 2, for example, 1 part A, we multiplied 3 by 12 to get 36, 8 by 5 to get 40, but then we also had to simplify that fraction, so we divided numerator denominator by 4 to get the 9/10. But the main kind of encouraged official way that we actually did it was not by first multiplying across numerator and multiplying across denominator. Since we're trying to give a simplified answer, it pays to just simplify it right here and right now. The idea is you can cancel a common factor in the numerator and denominator just right away. The common factor to 8 and 12 is 4. It's a factor because 4 times 2 is 8. 4 times 3 is 12. So when we canceled that common factor of 4, we just left the 2 and the 3. Then there was no other common factors to cancel. We just multiplied across the numerator and then the denominator. So we only actually use this formula at the final step after canceling all common factors, or as many common factors as we saw. So we're going to extend on this idea to divisions of fractions, then addition and subtraction of fractions, and that'll get us set up for doing some of the larger problems in this unit. I'm getting used to saying unit 2A as opposed to section 2A. Probably should change this as well. Oh, I didn't actually say unit or section there whatsoever. So let's start with the first official problem for the day. Let's leave this one here just as a guide. If we go over from multiplying to now dividing fractions, the process becomes a little bit different. To divide two fractions, we multiply, they threw a new word at us, the dividend, the very first fraction, so that's the dividend, by the reciprocal of the divisor, the second fraction. So we took this divisor right here. If we're taking a over b divided by c over d, we convert back into a multiplication problem. That's kind of nice in a way because it means we're just doing like this problem over here in part C. But we just have to recall to take the reciprocal, which is a fancy mathematical way to say flip the fraction. I think I prefer saying just flip the fraction a little bit over the technical version, take the reciprocal. So if we flip the fraction, this is essentially all we're doing, repeating a fraction multiplication. Well, any questions about the definition so far? Okay, let's give this a try. First, notice how dangerous example 2 part A is in a particular sense. We really have to do this step first, no matter what. If this said multiply right here by the red dot, we would have done pretty much what we did in part C, cancel the common factors. We would have divided 3 here, leaving a 1, divide 3 here, leaving a 2, but actually that's an incorrect step to take. So for this particular process, let's put here just as an emphasis, do this before canceling, or else we could make a mistake in the problem. So we'll take this 3/2, rewrite the whole problem as a fraction multiplication of 1/6. 1/6, that's kind of hard to say today for some reason, now multiplied by 2/3. And from here, it becomes a problem just like before. Now we could multiply across the numerators, across the denominators right away. Then we have to simplify the result. Or we could just simplify it right here and now. Any questions at all, folks, with that very first step there? Okay, essentially pretty much what we're doing with these few examples is really just the very first problem that you saw in the MyLab statistics on working out some fractional arithmetic problems. Here, we have a common factor that 2 does divide 6. It divides itself over here. So divide by 2 here to leave a 1. Divide by 2 here to leave a 3. And now we're pretty much home free. From example 1, we know we need to multiply across the numerator, but 1 times 1 is just 1. Multiply across the denominator, take 3 times 3 for a 9. And that satisfies the entire problem. Well, any questions at all getting through this one? Okay, we'll practice a few more just to get a feel for how all these go. Then the one process that we know is coming, we'll take a little bit more of a careful look at. We'll also look into adding and subtracting fractions, which we know gets a little bit more messy due to the least common denominator requirement. So let's try this out again. Some of the problems feel pretty straightforward, but some of the problems that we've done in these notes are a little vague in a certain sense. And this is one of those vague problems because now we're taking an actual bona fide fraction, we're dividing it by an integer, -28. We want to make it look like that, an actual fraction like c over d, but the trick we discussed from before is any number whatsoever, say like -28, you can just rewrite this in any way that's convenient. And what's convenient for us is you could rewrite this as -28 over 1. Not a strict requirement, but if you're trying to visualize taking the reciprocal, sometimes it's good for the eyes to actually see what the numerator really is and what the denominator really is. So making it an actual fraction altogether. So let's start this problem. Say 7/10 divided by -28 is going to be 7/10 divided by, I'll put the negative sign now in the numerator here, divide by 1. Let me just fix that penmanship a little bit. So we're always taking the reciprocal of just the second fraction. So that means this one will become 7/10. Now it's converting to multiply by, take the reciprocal here, or just flip the fraction. The negative sign, turns out you could put it anywhere you like, but I'll just keep it where it is at the moment by -28. We get 1 over -28. And now we're all set up for the next step. Again, at this point, this is kind of nice in a way. These division problems just regress back into an example 1 type of problem. We just convert it into multiplication and go from there. Any questions or comments at the moment? Okay, well, let's start to divide this through. With the 10, doesn't look like we can do anything much with that. But this 7 here can divide into the 28, the -28. It'll go into itself once and into -28. The way you write this is kind of tricky. Sometimes when you cancel this out, sometimes people visualize this as the negative also canceling. But let's visualize this as the 28 is the only part that cancels. I'll try and make that a little bit different slash. And the negative is still right where it was. Divide that by 7 and we'll get a 4 here. Now we're multiplying across the top for a positive 1. We're multiplying across the bottom, but it's going to be a 10 times 4 times, well, there's a negative there, which officially is a negative 1. So we'll get to negative 40 in the denominator. So the answer is 1 over negative 40. But there's a lot of different ways to write this. I think the most common way that this would be written is really negative 1 over 40 in that way. Either version is correct. So if you left it like this, I'm not too worried about that. But you'll most often see the answer expressed in this way right here. Any questions at all getting through that second version? Okay, let's maybe do just a really small aside with this. You'll notice the negative signs seem to move around a lot, and it feels kind of random sometimes how that happens. There's nothing really magical about it going on. Really, it's just a property of ordinary arithmetic that's allowing this. So to really see kind of what's going on there, let's put it in just a bit of a break and discuss a little bit about those negative signs. So the idea with that negative sign is when it comes to fractions, let's write it out as a sentence. In fractions, a negative sign can be placed out front. By out front, I mean like how we wrote it over here. This is really just shorthand for negative 1 times 1 over 40. We just write that as negative 1 over 40. Or in the denominator, or the bottom of the fraction, like it's written down here. So it can just move from out front to the denominator if we want, like it's written here, or the numerator. Let me spell that correctly first. Numerator, sounding it out helps. So if we wanted, we could take that negative sign and just place it on top and rewrite the whole problem as negative 1 over 40. It turns out no matter how you write it, all three versions are correct. And I'll never be picky of where you throw the negative sign. I only mentioned that this is more common, like if you're reading a textbook, that's how they'll typically print it out. So that's kind of a weird idea, but the way it works is, let's just see this through a particular example. If you had, say, something like maybe it's 1 over negative 3. If you want to rewrite this with a negative sign up in the numerator, here's how you can make that happen. You just go 1 over negative 3. We can multiply by a brand new fraction, but we never want to actually damage that inequality. So we have to be careful with what fraction we multiply by. I want to eliminate that negative sign and keep it a 3 below. If we multiply negative 3 by negative 1, that will force it back to a positive 3. But now, to force that equality sign to be maintained and unbroken, we have to put a negative 1 in the numerator as well. Really, if we take a number, divide by the same exact number, that's just 1. And 1 times anything results in the original quantity. So we're still looking at the same numerical value by multiplying by this weirdly disguised 1 over 1. To do that multiplication, you'll get negative 3 times negative 1. Property of signs say the negative signs cancel, it's just a positive 3. And 1 times negative 1 would give us a negative 1 like that. So that's how you can convert the negative sign in the denominator way up into the numerator if you like. It works in the opposite direction. You can move it from the top to the bottom. And same kind of concept will show why it's equivalent to this one as well. Well, really, that's just another kind of interesting topic that comes up with fractions. where you decide to place the negative signs. Any questions with that short remark in the middle here? Or other questions at the moment? Okay, let's try out one more. Here's our part C. Slightly bigger numbers, but if we just follow our nose on how this should work out, it's going to be the same kind of work just like before. Notice we can't cancel anything at the moment. We want to convert to multiply first, then start canceling things and simplify the result. And just for the sake of practice, probably what's a good idea to do for some of these problems is give you all the opportunity to give a try. The more active you are when you're working through this course along with me, the much easier it is to kind of retain this information, build the skills to get us through the course. So being active might mean you printed out, say, the notes here, and you're filling them out, solving the problems as we go, following along with me. Or maybe you downloaded the note here or the Word document here, and you're working digitally as well. Those would be great options. And either case, sometimes for these problems, it'll be a good idea to just let you give it a try. So let's make this one of those kind of problems. It's kind of weird because I'm all alone in the classroom. I don't know exactly what you're doing. But if you have a pencil, pen, notebook paper nearby, or you're working with digital tools, let's give a couple minutes just to think about this problem, work it out on your own, and then we'll do it together as a class. I'll show you how I would have done it, and then you can compare work against what you did and what we'll put here on the notes. So I'll watch the clock here. Let's give this one, say, until what is a good amount of time? A few minutes. I think that seems about right. Let's take a break to think about this problem, try working out the solution on your own, and we'll give it a try as a class at 6:30 sharp. I'll be quiet now. Okay, we're at 6:30. That was 3 minutes actually felt like a long time on my end. But let's see how we did. Any volunteers over voice or over chat to say what answer you came up with?
I will.
Awesome.
Do you want me to explain it through or just give you the answer?
The answer would be just fine. Yeah.
I ended up with 1/2.
Awesome. How do folks feel about that? Does everyone agree? Anyone have a competing answer to take a look into?
Mine's the same.
Awesome. Thanks for the feedback and engagement on that, folks. This is kind of a weird way sometimes to do a math class too. I mean, mainly because this is over Zoom, but occasionally I think it'll be a good idea for me to not just completely talk through the entire lecture and give you an opportunity to try it out. Well, let's see how this is going to come together. First, I like how we all got the positive 1/2. There's two negative signs, but that's really just a distraction at this point because both of those cancel just immediately at the very beginning. So those cancel off. Then we take the reciprocal of the second fraction, just like the problem above in part B. This is now 21 over 30 times 5 over 7. My goal is to keep on connecting the dots, essentially, the equality sign, until we get to the provided answer, 1/2. But you know what? We're pretty much there. Maybe I should have wrote that a little bit closer. We could multiply across the numerator right here, but now I'm looking at a number that's quite large divided by an even larger number. But simplify right here, it's a little bit more fluid to get through the result. 7 goes into itself once, into 21 3 times. Likewise, we can divide 30 by 5. So divide by 5 here to get a 1, divide by 5 here to get a 6. And some people might have continued to cancel. I think that would have been just great. Just for the sake of the notes, so it doesn't get too busy right here, let me multiply across right now. I now have 3/6 multiplied across the numerator and denominator, but this reduces further. If you divide the numerator by 1, if you divide the numerator by 3 and the denominator by 3, that'll give us the 1/2. Well, any questions at all, folks, on getting through that one? Okay, thanks for giving that one a try. And again, this is kind of new territory for me, trying to do a sort of not exactly group work, but giving you a chance to try out the problem on your own. Let me know how that felt on your end. Was the wait time too long? Did you need more time? I'll be happy to know about that. Well, let's move on to the next problem there, unless there's any questions or comments so far. Well, we're just about through the review of fractions. Last concept we're going to take a look into is addition and subtraction of fractions. Oh, and I just noticed the chat. Awesome, glad to hear that, Amy. Amy says their wait time was just about right. Awesome. I'll try to make sure that we're not just kind of bored waiting too long or feeling like you're rushed. It's kind of hard to get right in the middle there. So thanks for the feedback on that. Well, as far as addition and subtraction of fractions go, there's really two formulas here, but this is really one kind of main idea. Whether you're adding or subtracting the two fractions, the major thing that we want is a common denominator to make the process work out right. So I have a fraction a over c plus b over c. Once we see that, that's kind of a nice thing to have in a problem. That means we can just add directly across the numerator and maintain that common denominator. Likewise, if you're subtracting and you have the common denominator c, all you have to do is duplicate it once more and then subtract across the numerator. Only requirement is your denominator cannot be 0, and then we're in business. That makes this problem kind of nice. It has a common denominator, it's 21 on both. So this one immediately just becomes 1 plus 13 over 21. You might have wrote 14 here already, and that would have been just fine. I'll take an extra step. Sometimes it's good to just show a paper trail and how it comes together in the notes. We now have 14 over 21. And if this was a real exam question, say maybe it's a 5-point exam question, just like on the other problems, we might lose 1 point right here if we ended, because on this particular example, it does reduce further. We want a fraction in its most simplified form. Looks like 7 seems to be dividing a lot of stuff on these notes for no particular reason. But we can divide numerator and denominator by 7. 7 goes here twice, goes here 3 times. Sorry for all the 7 divisors on the notes. And the result is 2/3 altogether. So if you take 1 over 21, a very small proportion, plus 13 over 21, that's quite a large one, a little bit over half, it tells us we get 2/3 of an entire quantity. So if you're good at visualizing things, you could think of this as 1/21 of a slice of pizza plus 13/21 of a slice. I don't know how you slice with 21 pieces. That's got to be a sharp knife. But if this ever happened, you add those together, that's 2/3 of the entire pizza. So that's the world of adding and subtracting fractions. The real computational side of this gets a little bit more messy the moment the problem starts out without the common denominator. That's where we have to start working just a little bit harder. But any questions or comments at the moment with the first warm-up problem? Okay, let's try out another then. So again, here's our challenge with this one. We have 5/12 minus 1/4. We cannot proceed as before. We have to, as a very first step, first find the least common denominator. And it's really not too bad for a lot of problems. First, let's think about what do we even mean when we say least common denominator, often abbreviated as LCD for least common denominator. You'll know you have a least common denominator when this is the smallest number both denominators divide evenly into. Oh, let me scroll just a touch. There we go. So the least common denominator is some number that both of those denominators, 12 and 4, will divide evenly into. Well, you know, if you think of the number 48, that's a great number. 12 will go into 48 4 times. 4 goes into 48 12 times. This is a common denominator. But we could do better. The L here is pretty important. We want the smallest number that both of those denominators would divide evenly into. If we work with 48, it'll get the job done, but then we might have a ton of work to do to simplify the fraction. So what the least common denominator is really all about, finding the route that's going to cause you to do the least amount of work simplifying and still subtract the fraction accurately. So we got to do better than 48. Anyone see what the true least common denominator would really be in this problem?
Would it be 12?
Yeah,
Jinx.
good call. This one is just a 12. Yeah, good timing on that one as well. 12 is a great number on this because we can now say the least common denominator is 12 since, well, 12 will divide into 12. Goes in once. 4 will divide into 12. Goes in 3 times. And we can't make that number any smaller. This is the smallest such number that will work. So this is just a short discussion on finding that least common denominator. Here's what the work would actually look like on paper. Notice we have half of the denominator or half the least common denominator already. We don't have to change 5/12. We can just copy it in directly. So here's 5 over 12 minus 1 over 4. We have to do something to this fraction. But the big idea is we multiply it by the number one. The number one comes in lots of different shapes and forms, lots of different disguises. We're pretty much going to do one of these kind of concepts again. We're not going to multiply by -1 over -1. We have to pick the right value to use. So we ask ourselves the question, what can we put here to multiply the 4 and get a 12? Kind of the hint on it is that 3 right there. If we multiply the bottom by 3, then 4 by 3 produces the 12. We just have to make sure we don't ever change the equality here. We want the numerical value to be exactly the same. So we just multiply by 3 over 3, just a convoluted way to multiply by the number 1, essentially. So here's what the next result will be. 5/12 minus, now across the numerator, this will be a 3. Multiply across the denominator, and we get a 12. Forgot to color code those, we'll just slap it with the highlighter. But that's exactly what we wanted. We now have pretty much the same problem like part A, just a different denominator. Once we have that common denominator, we can rewrite the problem as this is nothing but 12 in the denominator, the common denominator, with 5 minus 3 in the numerator. Let me move the notes down below for how we're thinking about this. Then we just keep going. 5 minus 3 gives us 2 over 12. This one reduces as well, so let's divide by 2, numerator and denominator. 2 goes into 2 once, goes into 12 6 times. And now the whole problem ends as a positive 1 over 6. So we did it, folks. This one is not as friendly as part A, but with just one slight correction, change the second fraction by multiplying 3 over 3, we made the denominators identical. And I think that's how a lot of people tend to think about least common denominator. Its full definition is down here in orange, the smallest number that both denominators divide evenly into. But if you ask yourself the question, how can I make the denominators identical? And just realizing you're multiplying by 3 across that denominator, this is essentially how a lot of people end up doing this kind of work in the end of the day. Well, that's our first fraction subtraction. We'll do one more. I think that's just one more, and switch to a couple more concepts before getting to the next part of the notes. Any last questions at all, folks, on the part B? Okay, let's try this out once more. Part C is again one of those slightly more annoying problems because now we're taking an integer, a whole number 6, minus an actual fraction, 6 over 7. But our strategy all along has just been, you can revisualize this by promoting the whole number 6 to a bona fide fraction. So that 6 there can be rewritten as 6 over 1 minus 6 over 7. Then this one really isn't too bad compared to part B. We can make the denominators identical by forcing a 7 right there where the red dot is. In other words, the least common denominator in this problem happens to be a 7. So let's write in an extra step just so that that line doesn't get too busy. Take 6 over 1, multiply by 7 over 7, minus 6/7. It becomes a fraction multiplication problem, just like example 1. 6 times 7 will make 42. Divide by 7, minus 6/7. Again, forgetting the color coding there. Let me fix that. Then finally, at this stage, we're pretty much home free. Take 42 minus 6, divide by 7. When we write down that 7 once, it's our denominator now. And so 42 minus 6 will give us 36. Divide by 7. And suddenly, we're kind of done here. 7 is a prime number, so the only way it would divide into the numerator is if it was a multiple of 7, say like a 35. But this one is not divisible by 7 like so many of the other problems we did in the notes. It's simplified right here, right at this step. Yeah, some people might not like to just leave it like that. You might convert it to a mixed number, but you really don't have to. It's just fine just the way it stands. So if you ended the work right at this step, that would be acceptable. If you did convert it to a mixed number, no harm done. But just know that MyLab is sometimes kind of restrictive on the number form. If you wrote that out as a mixed number, you might not be able to actually enter in the mixed number into the system. It might actually want the fraction that we see here. So this one, it looks weird because it's an improper fraction. Not improper because it did anything wrong. It's just fine just the way it is, but it's improper since 36, the numerator, is larger than 7. Should define these new symbols the moment we say them. That's the greater than or larger than symbol. But it's still in a perfectly fine simplified form. So that's pretty much the landscape of adding and subtracting fractions. I notice we primarily subtracted them. Oh, we did do one addition. That's good. But whether you're adding and subtracting, the main meat of the problem is just matching up your denominator so you can do that operation in the middle here. Well, any last questions at all, folks, on getting through the fraction arithmetic?
On the, when we're taking the test, because it's not
Yeah.
online, would you prefer us to leave it as an improper fraction or write it as a mixed number?
That's a great question. I would say really it's going to be mainly up to your preference. I'll accept both. I will never be too picky on either a quiz or exam situation. One thing that could happen though, now that I think about that, that's kind of a multifaceted kind of situation. Because if it is an exam, we're kind of working under a time constraint at the same time. A 75-minute exam is not going to make you work to the very minute, 75 minutes, but still it pays to be kind of economical with your time in an exam setting. And so if you get to an acceptable answer on an exam, usually that's a good stopping point. It takes more work, not that much more work, honestly, but it does take more steps to get it to a mixed number. And so you might want to use that time elsewhere. And let's imagine a scenario where you did take more steps to convert it into a mixed number, and you did make a mistake. Maybe you said it goes in 4 2/3, just something random like that. In that scenario, I probably wouldn't take off a point. Probably what I would do is just box off that spot where I would have felt like you got it right at that step and you could have stopped there. I would have marked that correct and you would have been just fine. So kind of either way you do it, it's up to your preference. If you took an additional step, but you were correct here, it's not really going to hurt you. Other questions so far? Okay. Well, this is, again, I think we mentioned on day one, the first 3 examples of the course are mainly just kind of a getting everyone on the same page kind of set of problems. They're also very helpful since we'll be doing a good amount of fraction arithmetic in this chapter and in these notes in particular. I want to give you a tour of what we're going to be doing next. Examples 4 and 5 still are working with fractions, but this is more about conversion between a decimal form and a fraction form. Here we're in a decimal form we'll want to write as a common fraction. Here we're as a fraction wanting to convert back to a decimal. That'll be useful for some of the work we do and these notes. But the major kind of problems that we want to solve, this is the bigger bulk of the homework in MyLab, is solving problems like these. They're situations that have units, so I guess we could call them word problems, even though they're not that long. We'll have to decide on which operation are we really taking, how the units are going to be working. Essentially, this just turns into a little bit more fraction arithmetic with a story behind it, with actual context. This one's about a water tank. So that's what we'll be doing with the rest of the notes. We'll do a good amount of problems today and finish out the notes 2A when we come back on Thursday. So just a couple more concepts with fractions, more about conversions this time. I found this word to be kind of weird, but I copied it verbatim from the reading in the book just to make it more familiar for when you're doing the problems in the MyLab system. A common fraction is kind of a weird wording, but what we mean by a common fraction is a fraction that has a numerator and a denominator. So that's the meaning of a common fraction. This one's a decimal number, 4.5. And the trick to converting this into a common fraction is to think in terms of place value. That 5 there after the decimal point is 5/10, so it's in the 10ths position. So that's the major observation for this one. This 5 is in the hundredths position, but the position that's more relevant to us is the final digit in that decimal expansion. We're at the tenths, the hundredths with the 5, and then the thousandths here. Thousandths. Position on the 1. So making those two observations allows us to now make the conversions. So here's another way to re-express 4.5. We can say that's just the same as 45. We write the number just without the decimal point whatsoever, divided by 10. Matching up with what we said here about the tenths. Maybe I shouldn't have used that color. Let me fix that for the sake of color coding. So the 5 is in the tenths position, so we're just dividing by 10 in this one. So now it's a common fraction. We still have to reduce that fraction, so let's do that on the next step over here, 45/10. Any number that ends in a 0 or a 5 is divisible by 5, so it's to divide the numerator by 5. 5 goes into 45 9 times. Divide the denominator by 5. 5 goes into 10 2 times. And it's just a 9/2. You probably might have already known that 4.5 is just the same as 9 divided by 2. If you have a calculator nearby, oh darn, I forgot to load one in, then you could just do the computation real fast to verify. But this is more just the process. If we had a weirder looking fraction, like say 0.051, the process you'll see here is pretty valuable for doing the conversion on this one. So that's a strategy. Let me take a small detour here to load in the calculator. Try to remember to do that next time. We mentioned last time in class that we'll need a scientific calculator for our coursework and for exams. And I'll be using this one just for the purposes of strictly classroom demonstration. I find this is a fast calculator to load up and have just as a quick little side panel in a class like this one. So, okay, now that we have the calculator up, just a quick check. 9/2 is indeed 4.5. It's kind of a nice problem with an immediate check. But now let's take a look into what's going on with 0.051. We really just take the same kind of strategy. Write down that whole number without the decimal point. We omit the zeros, so we start with just the 5 and the 1. The numerator is now a 51. If it says thousandths, then that just means we divide by 1,000. Now we have to wonder, are we done or do we have to simplify? If 51 was a prime number, that would inform us if it's simplified or not, because 51 couldn't possibly divide into 1,000 evenly. It's a large number, so, oops, sorry about that. You might want to have a calculator companion nearby. 1,000 divided by 51 is not an even division, so it can't reduce in that way by dividing 51 here and down below. But now we wonder, does something divide both 51 and 1,000 at the same time? If the numbers are bigger, that could be an even tougher question, but a quick way to check is, let's see what could potentially divide 51. 2 cannot divide because it's an even number. We know 3 will divide this one. If you take 51 and divide it by 3, we get a result of 17. So 51 as a factor tree is just 3 times 17. So if 3 were to have divided into 1,000 evenly, this fraction reduces. But it cannot. This is an even number. 3 can't divide 1,000. Likewise, the prime number 17 cannot divide 1,000 either for the same reason. So it turns out this is the answer. It's just 51 1,000ths. Maybe the trickier thing about this problem is just to double check if it reduces at all. But we got it, folks. That's just converting from a decimal form into a fraction form in case we ever have to do that. And if it can go in one direction, we should be able to reverse it as well. This might be the more common direction that we go. From a fraction into a decimal form will be the more typical process. But we put in example 4 because it's good to see it both ways to understand either direction. Any questions or comments at all with that example 4? Okay, I think you'll like example 5. Really, if you have a fraction and you want to go into a decimal form, really not, oh, sorry, wrong icon. It's this one on the right. It's not a big deal in this class. You're allowed to have a calculator as a side companion. For homework, it's strictly highly encouraged. Try to use the same calculator for your quizzes and bring in that same calculator when you take an exam. And this is nothing but a calculator operation. To go to a decimal form, just take 5 divided by 8, and the job is done right there. The fastest problem we've done all semester, probably the fastest problems we'll ever do. It's a 0.625. I'm not too picky how you write this, and neither is the MyLab problem. If you write 0. I already forgot the number, 625, that's more of a standard form for answering it. If you left it as just a 0.625, that's fine as well. That's a very acceptable shorthand. So I'll leave that purely up to your preference. Kind of like the mixed numbers, this is really just a stylistic way of writing down the problem. Well, these go really fast. Any questions at all with part A? Okay, the problem doesn't say anything about rounding, so it's always assumed we're going to go for the exact value if there's no rounding information. And MyLab is pretty rigorous about that as well. If they say just convert to a decimal, we have to put in all these values. We couldn't round it to say 0.63 or anything like that. So when it comes to 2/3, that makes it, dang, I did that again. Maybe if I move this in front, that's going to prevent me. There we go. Let's move that around. When it comes to 2/3, it gets kind of awkward because now we have to decide what should we put down. The answer is not 0.666666. I'm losing track of sixes, 7. The calculator rounded on us right here to give us that 7. Some calculators round a little bit differently, but even if it said 6 there, that's also not the answer. These are just approximations. The decimal number for 2/3 is a repeating decimal. It's unending, and the moment you stop writing down a 6, you've approximated. But we have a way to say this in a nice way. And recall the trick to represent 6 repeating forever?
A line over the third 6 at the end.
Yeah, exactly, Caitlin. Thanks for mentioning that. It might have been kind of a while since you may have possibly done that. So just as a refresher, if you determine the decimal is repeating, just like on this one, go 0.6 and a line above. So that'll be the exact form of this number written in as a decimal. Decimal numbers have, their own weird little issues. Just like fractions, it's kind of like its own world with the way those operations work. The decimal numbers have other interesting, weird things that can happen. It could repeat one number, 6 forever. Or some numbers could be 621, 621, 621, repeated forever. If that's the case, we put the bar above just the 621. And other decimal numbers are even stranger. Say, for example, numbers like pi. This is an unending decimal, just like 0.6 repeating over here. But there is no block of numbers that ever repeats on this forever. So we can never use this trick whatsoever, making pi kind of a weird number. A lot of computational effort has gone into just finding out as many digits as possible to this number. but we're not going to deal with too many crazy kind of approximations like that. This will be a more typical kind of problem that we'd be working in the homework. And Amy says, how do we show a repeating line on the computer? You know, that's a really good question. Let me double check on the system to see how that might work. So let me take a quick look into that. Usually the system is pretty good about popping out the mathematical notations and tools that you'll need from a problem by problem basis. But I don't think I've actually seen that bar that I need for repeating decimal, like the problem that we just solved. So let's take a look at this together. That's an excellent question. I want to go to student home. There we go. This is more typical for what you'll actually see. And let me see if I can find the right question that matches up with that concept. Question 1 is strictly just fraction arithmetic on this one. So let's see question 2. Right, each of the following is a common fraction. So that's the one we practiced before the current one. Convert the following fractions to decimal form. Okay, let's see if any of these are repeating. Here's a 2/3. That's kind of nice. But you know, I can't skip to part C. That's kind of annoying. We have to do this in steps. But we're learning the system, so this is a good little break to take to see how this goes. Let me move that control over there. So if I was doing this as a homework problem, this one's a nice one. You're encouraged to, I mean, you could do long division if you prefer and you like to, but we're not going to go too heavy into those kinds of arithmetic things. You're just fine putting in the decimal number through the calculator. So imagine this is your calculator that you're working with. 0.75 should go in. And here's the controls it gave us. Looks like none of those are needed at the moment. I'll just hit enter. And it gives us a little reward there. I guess that's maybe possibly gives us a dopamine hint of some kind. We'll probably become numb to that after we see that over and over again. Do it again for 1/8. So this will be 1 divided by 8, 0.125. Let me write it differently, 0.125. And 2 down. Notice we didn't have to put the 0 in front of that one. And if we decide to put in the 0, MATLAB doesn't care. It can tell we're talking about the same value. And this is the interesting one, 2/3. Repeating what we would have done if this was, say, a real problem. We've got the 0.6 repeating. This one's a little different. Now that I'm looking at this really carefully, it's asking for rounding on the instructions. You know, it looks like the bar actually doesn't come up in the homework system, possibly because of that. So if I'm rounding this to the nearest thousand, well, this might be a good one to just screenshot into the notes. Essentially, we're just going to put that 7 you see there in Desmo's calculator in just the right position. So let's put this back into the homework problem. Maybe that wasn't the best problem. Looks like it's asking us to round on some of those. And let's say this one is from MyLab. So the instructions look a little bit more similar to this, round to the thousandth as needed. This one did come up. This is 0.125 and 5 is in the thousandth position, so it didn't need rounding. And so now here, just a real fast refresher on rounding. Rounding will come up a couple more times in the notes. We have to know the place value we're dealing with. By thousandths, we're talking about the third decimal point here. This will go tens, hundredths, then thousands here. So here's the thousandths, that third 6. Once we know what place we're rounding to, we take a look into the integer to the immediate right. That color is plum, by the way, if you're curious, is what Microsoft Word says. So that's going to be kind of hard to target. Let me go for a circle. No, let's go for an arrow. That's going to be easier to see. For rounding to the nearest thousandths, that 6 there, where the orange arrow is pointing, we move one place more to the right, to this place, and if this place is 5 or larger, round up. The number that's actually rounded up is what the orange arrow is targeting. So the answer to this one will be equals point. Oh, there's an equal sign already there. Let me take that off. 0.667. So sorry, it looks like I don't have a great answer to that. Looks like that kind of problem won't come up in the homework system. Let me just double check with question 4. You have not completed this question. Receive credit only for the work you've done. You're sure you want to leave this question. That seems foreboding. Let's say yes. We just left that question where it stands. But that's okay. You can just come back to it and fill it out if you would like to switch gears and look at a different problem. And yeah, this is pretty much the end of the fraction work. So looks like repeating decimals doesn't actually come up in the homework. Sorry for the distraction of doing it here in the notes, but hey, at least we have 2 different views on that. And thanks again for asking the question on that one, just to get a good feel for what does it really look like in the homework. Well, any last questions at all, folks, on example 5 or other? Okay, well, this is kind of, again, the completion of getting everyone on the same page content on this Unit 2A notes. For the next unit, we're going to look into a couple different types of applied settings. Really, it's more fraction work like we've been doing before, except now there's context. Notice the unit title for this section is Understand, Solve, and Explain. And in the reading, the book has a lot of things to say with each one of these. I put in just the abridged version for step 1, step 2, step 3. This is a process that is just a great way to think about a problem that could be complicated, not easy or clear to know how to even start. This is a great process to work with. Other definition from the book is we're going to be using units to see how things line up in the problem to make sure we have even the right quantity in the first place. And all we mean by unit is some kind of description of what our numbers actually represent. For example, when we said, say, 2/3, we might have meant 2/3 of a pizza. Pizza would have been the unit in that kind of situation. And unit analysis is something we'll do a little bit here and there whenever units come up. It says it's the process of working with units to help solve the problems. But in other words, it's a great way to determine, do you have the right quantity in the very first place? If you're expecting an answer in, say, dollars per hour, but you carefully worked out the units and you got hours per dollar, you might be worried that something might have gone wrong in the problem. We don't have the answer we were expecting. So let's work through this. Understand the problem is really just visualizing, understanding what the context is all about before we even launch into it. And a big part of understanding that problem is knowing what the problem even wants us to compute in the very first place. When you do this kind of problem in MyLab, it's a little bit more directed because the problem looks a little bit more like this. What is the unknown? You would just select one of these as kind of a multiple choice kind of question. Do give it your best effort on this. You do have unlimited tries on these kind of problems, so there is a way to just do it through exhaustion and elimination by just trying. But if you did it that way, the homework system really isn't going to help us a whole lot in really understanding the material on the quizzes or the exams. So try to give it your best effort, knowing that if you get it wrong, it's not too big of a deal. If you're ever not sure why it's wrong, don't hesitate to ask about that problem. I'll be happy to help out. Doing it on paper, again, feels a little bit different. Here, we just have to say it straight out. So that means MyLab as a homework system is not exactly the same experience that we're going to have when we do a problem, say, on paper, like example 6, or if we did it on a quiz, maybe quiz number 1, or if it comes back on an exam. That's an important thing to be aware of. That's really the major purpose of the quizzes. If I feel like this is a good exam problem, think of the MyLab homework as this is kind of just a warm-up. It's a little bit easier when it's multiple choice for sure, but if this made a problem that could come back on an exam, it's potentially going to be a quiz, and a quiz is a harder way to do this problem. We're doing this problem as if it was a quiz problem as well. It would also be similar to how it would be done as an exam question as well. So think of the MyLab system. It's really just for extra practice. Good questions that make it to exam questions will be written out as quizzes as well. And it'll be something very similar to what we see here. Example 6 starts off by saying, a water tank holds 25 cubic feet of water. How much does it weigh? That's a great question. If this was a real exam question, I'm required to put in this kind of information. You're not expected to just know these random kind of facts just out the back of your mind that a cubic foot of water is 62.4 pounds, quite heavy actually. So in solving this problem, it asks, what is the unknown? Sometimes you can see that by, once again, in step 1, understanding the problem, just reread through it again, and a question mark could be a pretty big giveaway. How much does it weigh? Is the unknown, so the answer to this will be the weight of the water in pounds. Or you could say in some other unit, but if they gave us something involving pounds, probably a good idea to stick to that same unit. So part A isn't really anything too major. It's just us double checking that we know what we expect to solve when we go to part B, doing the computation. With a lot of these kind of problems, you could literally just kind of pick up a calculator, play around with the numbers, and see what fits. But that could be kind of a dangerous way to do a problem, once again, if it's on a quiz or an exam where we don't have multiple attempts. Part A becomes a little bit more critical because now we know our answer has to end up in pounds altogether. So let's now move on to part B. If we're going to calculate the total weight, the major thing we want to use is this conversion factor right here. It was written in kind of a weird way. 1 cubic feet of water weighs 62.4 pounds, but you can re-express this in a different kind of way. You could say, if 1 cubic feet of water, written in this way, equals 62.4 pounds, let me just write the unit as LB for pounds, then that implies you can make a fraction out of this. Divide the left-hand side by 1 cubic feet, and you would get 62.4 pounds divide by 1 cubic feet. Well, this is literally the number 1. This divide by this, if we change the units, just cancels out because it was equal right here as well. And you could rewrite this as 1 over 1 cubic foot divided by 62.4 pounds. In this way, you could just flip the whole fraction, and this would be equal to 1 as well. So now we use the fact that we have 25 cubic feet of water. If we want to know what that weighs, we'll take 25. It says cubic feet, but that just means there's a unit. Feet cubed. So let me put feet cubed here as well. And we have to multiply this by something, either this fraction here or this fraction. Anyone see which one would be the correct one to multiply by?
Would it be the 62.4 over 1?
Yeah, I agree with that one. The idea is we want to answer in pounds, right? This one has cubic feet in the denominator, but it has pounds in the numerator, which is the actual quantity we want. So if we take that, and as you suggest, multiply by 62.4 pounds, divide by 1 cubic foot, here's where our refreshing on fractions is starting to help out. Think of feet cubed just like another common factor. It can completely cancel out in that way as a unit. Division by 1 is just results in 62.4. So now all we're taking is 25 times 62.4, and we get 1,560 pounds. That's almost the weight of a car. So this is a really, really big water tank. 1,000, and I forgot the number again, 560 pounds. From part A, we knew the answer had to come out as pounds. So that's what directed us to using the right conversion factor, this one here. I noticed I ran over by a half a minute. Sorry about that, folks. We'll have to finish off part C when we come back next time. And this gives us a pretty good preview of what we're going to be doing on the rest of the notes in Unit 2A. But sorry for ending here right at the minute. Usually at the end, I call for questions with the understanding we have just a couple more minutes to go. But any last questions before we call it a night today? Okay, well, we'll practice this kind of work a little bit more when we come back next class with the goal of finishing, but we're not going to try to rush through the notes. We do need to take a little bit extra time to finish them off. We'll make sure to take that time. But again, have a good night. Sorry for running over. I'm going to try to do a little bit better with time management and watch that clock better. I know some people are probably doesn't matter as much, but some people might have somewhere to be. So sorry to hold you too late. Well, take care, and I'll see you all Thursday.
Thank you.
You bet. Have a good one.